Hello everyone, welcome to Make 2 Explore channel. First of all, thank you to all our subscribers, viewers, and supporters. In this session, we are going to see a tutorial of how to interface EM18 RFID Reader with Raspberry Pi 4. Also, subsequently we will learn about how to use UART communication of Raspberry Pi. We will program this tutorial codes in Python as well as in C language. So without any delays, let's get started. This is EM18 RFID Reader module, which is used to read the passive RFID cards or tags, like these. Module comes in this type of packaging. Also, it can be used with these types of breakout boards, which takes out its pins and makes it easy to interface with other MCUs. If you want to purchase this module and breakout boards, we will share some links in the description of this video, you can check them out. We will use this module to interface with our Raspberry Pi 4 board. But before that, let's know about passive RFID detection, in brief. So, we know that RFID stands for radio frequency identification. There are two types of RFID cards: active and passive. These are passive RFID cards. These cards do not have any active power source or battery inside them. If you cut these cards open, you will find these types of coil-like structure inside it. This is antenna coil. It is an induction coil on ferrite core or flat with many turns, which is connected to IC, very small integrated chip, which works as a transponder. The unique ID of each tag or card is stored in that IC. Here is typical block diagram of these kind of ICs, in which you can see different blocks like signal power generator, demodulator, encoder-decoder, interface control, and EEPROM memory section. This memory stores unique RFID code specific to that card. These all things compressed into this tiny IC. Okay, so this was all about passive RFID cards and their internal structure. Now let's see about its reader module. This is EM18 RFID Reader module. Here on reader side also consist of antenna. There is a copper coil inside, we can see it. So, how this all things works? Let's find out. So, when we give power to the reader module, RFID reader has transceiver, which generates a radio signal and transmits it through antenna. Like this. This signal itself is in the form of electromagnetic energy, which is used to activate and induce the power into the tag. On other side, RFID tag, which has this coil antenna receiver. When it comes in range of signal transmitted by the reader, transponder in the tag is get hit by the signal. A tag's antenna coil gets energized, it draws power from this electromagnetic field created by reader. Technique used here is also called as near-field inductive coupling. The transponder converts that radio signal into the usable power. After getting power, this transponder IC will get activated, which then fetches the unique ID stored in its EEPROM memory and sends it to the RFID reader in the form of RF signal. On other hand, RFID reader receives this RF signal, it decodes it, and then puts that unique ID data in the form of byte on serial TX transmit pin. This data can be used or accessed by PC or microcontroller serially using UART communication. So, in short, passive RFID cards or tags gets activated only when they brought in specific vicinity to the reader. This range of the reader is also called as its operating range. It varies for different modules. EM18 RFID Reader, which we are going to test, has range of 5 to 10 cm. Okay, this was all about the theory of RFID. Now let's see some features of EM18 RFID Reader. These all are typical features of EM18. Most important are operating frequency and range. There are various RFID readers available according to their frequency and operating range. Like EM18 and ILA12 operates at frequency at 125 kHz. whereas MFRC522 and SM130 operates at 13.56 MHz. Okay, alright. Now, let's move to the hardware section of this tutorial and see schematic or circuit diagram. Here is the one. All wiring connections are in color coding. Hence, you can easily track them. You will get this schematic on our GitHub page. Let's see about the hardware components included. Here is the Raspberry Pi 4 Model B 2GB version, which is interfaced with this EM18 RFID Reader. UART receiver pin, RX, means GPIO 15 of Raspberry Pi, is connected to transmitter TX pin of RFID Reader through this level converter. You can see here. This is logic level converter module. It is required since Raspberry Pi pins works with 3.3 volts logic level, whereas RFID Reader module works with 5 volts logic level. So, we cannot connect 5 volts directly to Raspberry Pi's any input pin. Hence, to avoid any pin damages, it is recommended to use this bi-directional level shifter device, which takes care of logic levels. Okay, now let's move forward and learn more about the UART of Raspberry Pi. Since we are going to receive or read the RFID codes through serial communication, we know that UART means Universal Asynchronous Receiver Transmitter. It is a serial communication protocol in which data is transferred serially, that is, bit by bit. Asynchronous serial communication is widely used for byte-oriented transmission. Data get embedded between the start bit and stop bit. Frame structure varies for different microcontrollers and development boards. This is typical depiction of UART data frame. In the Pi family of development boards, the Raspberry Pi 4, 3, and Raspberry Pi 0W contain two UART controllers, which can be used for serial communication. One is Mini UART and other is PL011 UART. Mini UART. By default, the Mini UART is mapped to the TXD means GPIO 14 pin and RXD means GPIO 15 pin on the 40-pin GPIO header. Mini UART is used for Linux console output, the log which we see at startup. The Mini UART port can be accessed using this TTYS0 device address in Linux. In our practical session, we will see the demo of how to communicate with Raspberry Pi through Mini UART. For that we will use FTDI USB to TTL module. But before that, let's see its theory. We are going to swap the UART port for our practical use. We will use PL011 UART. Why? Let's see. Mini UART uses the frequency which is linked to the core frequency of GPU. So as the GPU core frequency changes, depending on processor load, the frequency of UART will also change, which in turn will change the baud rate for UART. This makes the Mini UART unstable, which may lead to data loss or corruption. To make Mini UART stable, user need to fix the core frequency, which is not recommended. Also, Mini UART doesn't have parity support. Another drawback of using Mini UART is it has a smaller FIFO buffer than the PL011 UART controller. This can cause problems at higher baud rates as it makes losing characters more likely. Okay. Now let's see about PL011 UART controller of Raspberry Pi. You will also understand the reason why we endorse it for our tutorial of RFID reader interfacing. PL011 UART is an ARM-based UART. It has better throughput than Mini UART. The PL011 UART controller is not linked to the GPU core frequency. This means that the baud rate stays the same regardless of GPU speed. The PL011 UART controller also includes other features not present in the Mini UART controller, such as framing error detection, break detection, receive timeout interrupts, and parity bit support. But there is one disadvantage of using PL011 UART. It disables the Bluetooth wireless module. So, you will be unable to use the Bluetooth features of the Raspberry Pi. Hence, We recommend using the PL011 UART controller in any situation where a reliable data connection is needed or power consumption and processor speed are a priority. If you need to use the Bluetooth module on the Raspberry Pi, then you should use the mini UART controller. Okay, now, let's see how to swap the UART on Raspberry Pi. For that, go to Raspberry Pi desktop. Or you can also log in through wireless SSH and headless mode. Just follow along the video, which is self-explanatory. On fresh install of Raspberry Pi OS, by default serial port may be disabled. You can enable it from Raspberry configuration settings. This config menu can be accessed both from terminal window as well as from GUI. We have shown both methods here. Here, enable serial port and disable serial login shell console. Just note that you have to reboot the Raspberry Pi for changes to take effect. Okay, now after reboot, let's verify that serial port is enabled or not. You can check that from command line as well as from GUI. Here, this is the TTYS0, which is our serial port, the mini UART. Let's send some messages on this port. We have mentioned earlier in this session that, by default, the mini UART is mapped to the TXD means GPIO 14 pin and RXD means GPIO 15 pin on the 40-pin GPIO header. The mini UART port can be accessed using this TTYS0 device address in Linux. Connect the FTDI serial module, like shown in this diagram. We will now send some messages to our laptop through this mini UART port. So, here you can see whatever messages we have sent got received on our laptop through serial terminal. But, as we have explained in theory part, mini UART is unstable. So, let's now see how to disable the Bluetooth and use PL011 stable UART, which we will require for our RFID reader tutorial. Disable the Bluetooth from here. Then disable it from getting invoking after restart. For that, go to boot config file and add this given statement. Then disable Bluetooth-related services. After doing all these, reboot Raspberry Pi for changes to take effect. Here you can see, serial 0 is TTYS0, means mini UART, and serial 1 is TTYAM0, means PL011. These will get swapped after reboot. Let's see. Okay. After reboot, here you can see, Bluetooth logo is gone. Means it got disabled. And then list the serial devices in terminal. Here you can see swapping done successfully. Let's now send some messages to PL011 UART, that is, serial 0, means TTYAM0. Hence, in this way, we have successfully swapped mini UART to PL011 UART. Now we will see the codes, Python as well as in C language. To read the data available on serial port, we recommend using the PL011 UART controller in any situation where a reliable data connection is needed or power consumption and processor speed are a priority, such as in image processing, computer vision, and machine learning projects. So, here you can see whatever messages we have sent got received on our laptop through serial terminal. Okay, in this way we have seen how to set up the Raspberry Pi UART to receive the data serially. We will use this technique to receive the RFID data sent by EM18 RFID Reader. We will see Python and C programs. Okay. Now, first we will see demo of C programs. For that, open Code Blocks IDE and load first program, which is serial read. Here, you can see this is simple code to read whatever data coming on serial 0, that is, PL011 UART port, and then display it on terminal. We have connected EM18 RFID Reader module on serial port, so when we place any compatible RFID card or tag on the reader, it will read it and send that ID to Raspberry Pi. Here in the program, we have included all the required standard libraries. Pi-specific libraries like wiring Pi, wiring serial, etc. Then down here, defined serial port as TTYAM0 with baud rate of 9600. You can copy and verify this path from the devices directory. Here, this is the one. Then here in this while loop, if any data available on serial port, then we will read it using serial getChar function. And then display it on terminal using this serial putChar function. Okay, now, let's build this program. And after successfully built, we will run it. So here in terminal window, you can see. As soon as we place the RFID card on the reader, we are receiving its ID code. Alright, now, we will see another C program in which we will identify and detect users according to their RFID codes. So in this program, like we have seen in earlier C program, we have initialized serial port. Then, we will read the RFID code using this getCardUser-defined function. In main loop, we will compare that with valid RFIDs which we have saved in the program. You can then compile the program, which will also run successfully. Okay, this was all about C programs. Now, let's do the same programs, but using Python coding. For that, we will use Thonny IDE. We will see 3 different Python programs. One is for reading and displaying whatever serial data coming on serial port. Second is for reading RFID codes. And third is for detection. Same as we did in C codes. So, in this way, we have completed this tutorial. This interfacing and theory are very important for our next projects. Since we are going to use this EM18 RFID reader in our next OpenCV projects, face mask detection based gate opening system used as to trigger the invoking of camera module. We are also planning some more RPi for OpenCV based applications like face recognition security system, gesture controlled automation, etc. Stay tuned for more updates. If you face any difficulty in replicating this tutorial, feel free to ping us on Telegram, or you can also send us email at info@make2explore.com. We would be happy to help. Thank you.